Okay, so picking up with where we left off, talking about conjugate acids and conjugate bases. This is the next video whenever you have a chance to watch it. In your notes at the bottom, they have different examples. I've just copied 2 of the 3 examples. I didn't have room for the last one, so we'll do that one last. But just again, the definition that we're using is the Bronsted-Lowry definition, which is that it's either accepting a proton or donating a proton. So we're looking at where this hydrogen ion is moving to and from to determine what it is. So whenever I look at the very first one, for the examples, also this is going to be super important to understand buffers, which is a really big deal for weak acids and bases. So it's important that we understand these concepts now. It's going to make our lives easier later. Anyway, so when I look at the very first one, I'm looking at my 2 reactants and I'm trying to figure out which one has a hydrogen to donate and which one has a hydrogen that it could accept. And if you look here, all of a sudden we have water present. This is a hydrogen ion floating around in water essentially. So whenever you're looking at these, this hydrogen jumps over here. So this is my acid. It has a hydrogen to give. This guy doesn't have a hydrogen to give. So this would be my acid and this is my base. And then whenever this guy loses the hydrogen, if you cover it up, then it's just nitrate, the ion. And so then I have my nitrate ion over here, which becomes my conjugate base, because now it can accept that proton. Now it can accept that hydrogen ion. And so then over here is my conjugate acid. This is a hydronium ion, which I think is in your notes already, but we didn't talk about it, or it's on the next page. But a hydronium ion is water with a hydrogen attached to it. And so then the next one, also same concept. So here, this guy has a plus charge. It already has gained a hydrogen, so it has an extra hydrogen to give. If we took off a hydrogen ion, then we would have ammonia. We'd have a neutral compound. So this is definitely our acid. It has a hydrogen to give. And then this is water. It's going to be our base in this equation. And so it can accept the hydrogen. So over here we see that it did accept. It became the conjugate acid. So my base became my conjugate acid and my acid became my conjugate base. So ammonia is our base. It can now accept a hydrogen, and if it did that, it would go back this way. Okay, so hopefully that's making sense. We have the last one that we're going to do real fast. Give me 2 seconds to copy it down. Then we will have officially finished the first page of notes. So I see that I have a weak acid, and it is combining with water, which in this case would be my base. And it is going to hydronium ions and I ran out of room. That's okay. So for this last one, it's in your notes. So we have right here water, and then this guy has an extra hydrogen to give. It can accept and it can donate a hydrogen, which we'll get to that later. But right now, this guy has our hydrogen to give. It has that extra proton. And whenever you see that, you can look over here, it's already balanced, that it has lost one of its hydrogens. It went from H2 to just H. So this is our acid, and this is our conjugate base, because it can accept a hydrogen ion here. And then water accepted that hydrogen ion and became hydronium, so it became our base to our conjugate acid. Okay? If you have questions, you can always send me messages on Remind, Google Classroom, email, things like that. And that should be the first page of the notes. The next page continues on with that. It talks about the hydronium ion, which I've been talking about right up here. Gives you the definition of it. So we'll talk about that in just a little bit and work through these notes chunk by chunk, hopefully in 5-minute little segments.